Well, good morning, everyone. Like Aoife said, my name's Craig Summers. I'm a regional sales manager for Sika, and I look after the northern region for Sika. I'm going to take you through this basement waterproofing standard and solutions presentation incorporating watertight concrete. And then my colleague Seb, as you've already mentioned, will pick up your questions, which you should enter as we go along in the Q&A. And as Aoife said, we'll get to as many of them as we can once the presentation is concluded, but every question will be answered either via email afterwards, if not taken care of at the end of this. So here's what you'll see today. A little introduction to Sika in case you've never heard of us before. We'll look at the Get It Right initiative, some reference materials for waterproofing strategies and design, a bit on some systems and selection of those, a little conclusion, and as I say, the questions should be fielded in the Q&A, and we'll deal with them right at the end. Here's Sika in some numbers. A couple of years old now, but useful numbers from 2018. In 2018, we logged 85 new patents for new products or technologies, which I think tells a lot about Sika because we do like to sort of blaze the trail when it comes to products. We came from humble beginnings in 1910, but we now have over 20,000 members of the team in over 100 countries, 200 factories worldwide. And in 2018, we invested £180.8 million in R&D, and we turned over £5.8 billion worth of sales in that same year. These are our core values: customer first, always, sustainability and integrity. We have courage for innovation. We empower and respect both our own team and our customers, and we manage for results every time. Sika in the UK and Ireland. Our head office is at Welwyn Garden City in Hertfordshire, the picture on the top left. We also have offices in Preston and Leeds, and our Irish base is in Dublin. And across these sites, we have over 850 employees and turnover more than £240 million. These are the markets that we operate in within the UK. Engineered refurbishment, which is primarily repair products for bridges and other civils type applications. Roofing, a couple of our roofing brands you may recognise would be Sarnafil and Liquid Plastics. Concrete, we don't sell concrete, but we do sell admixtures and special products for both day-to-day and special use concrete. Waterproofing, primarily subterranean waterproofing basements and underground structures, but also liquids. Flooring for domestic, retail, public, medical buildings, and also car park deck coatings would be covered in flooring. Building finishing, which is primarily ceiling and facades and the like. Industry, primarily refers to the automotive industry and also distribution. And now you'll see these products in DIY stores, the Everbuild range. And we do have REBIT approved CPDs on almost all of these markets. If you're at all interested in them, then please get in touch. On to the subject at hand, we'll start with the Get It Right initiative. So the Get It Right initiative is a 2016 report that was compiled by leading figures in the industry, and it looks at costs associated with not getting it right, quite frankly. And without reading through all the little individual figures, the most sort of staggering one to take away is that 79% of costs were due to some sort of error. The report ranked the areas of work according to their financial impact should an error occur, and across all three spectrums, civils, buildings, and across the industry as a whole, concrete works was the leading cause, which we've highlighted. We've also highlighted basement waterproofing, which is one of the most significant areas in all three too, as you can see. And the two are sort of inextricably linked because one of the functions of basement waterproofing is, of course, to protect the concrete. And there are lots of others that you would expect to see on there: M&E, roofing, steel work coatings, roads and pavements, but they're massive sums of money. In order to get it right, you need to consider each stage of the life cycle carefully. And this has never been more true than when relating to the design of waterproofing solutions for basements. So everything from assessment through design, specification of the products, installation on site, after sales and maintenance. Like many aspects of construction, the detailing is absolutely critical, and any interface between products is always vulnerable. In waterproofing, we often talk about the 99% rule. If you get it 99% right, that 1% will be the issue. Even if the design is robust, it does rely on correct installation, and human beings do this. So therefore, errors and emissions can and do happen. It should be expected. So a whole waterproofing strategy is critical to the success. So not just the design, but also any site attendance is required, toolbox talks, assessment of the installation and the products before, during and after. And this is something that we believe in strongly at Sika, and we offer it on every project, regardless of size. We'll look now at reference materials for design. Primarily BS 8102, the 2009 revision, and which is, I quote, the code of practice for protection of below ground structures against water from the ground. And basically it gives guidance on the design of waterproofing methods in the UK. This is figure 1 from the standard, and it shows the principal factors and stages that need to be addressed to come up with a solution. So reading the bullets in order: design team structure, any risk assessment, classification of the water table, and the client's requirements and the intended use of the building. So the table on the right sort of walks you through the design process. So you have to take the structural design into consideration and then select a waterproofing type. We'll touch on those in a minute. And then consider if a combined protection is necessary. Selection of a primary system. Has buildability and repairability been addressed? And you can see it's a little bit of a snakes and ladders game at any point. If the answer is no, then that sort of throws you back to the start. But the idea of that is that by the time you get to your solution, you've gotten it right and everything that's been considered. So initially a design team is formed, and as well as an architect or an engineer, a sort of traditional design team, a geotechnical specialist will produce an SI report or the like, which will provide information on the geology and hydrogeology of the ground. And a waterproofing experienced waterproofing specialist, I should say, with a proven track record, which could be the manufacturer, should also be involved, as outlined in the British Standard. Once a design team is formed, a competent site investigation is required to take place, and this investigation will cover all of these sort of things. So the groundwater, so primarily the water table, if there are any variations seasonally in that water table, even things like water mains, you have to assume that water main may burst and what effect that will have on the water table, even if it never does. And things like the ground drainage, topography, obviously, and the permeability of the strata, and other ground conditions such as the presence of gases and VOCs and any other aggressive mediums that might affect it. It's also fundamental that the designer understands the client's requirements, both long-term and short-term. Crucially, whether or not the use of the space that's being protected is likely to change over time. Because if it's going to be a car park today, but then a habitable basement space in 10, 15 years' time, then this will affect how the waterproofing is designed now. With design, a pessimistic approach must be taken and the consequence of failure considered. What are the consequences of water ingress? What bearing is that likely to have on the structure? You should expect defects both during installation and afterwards. And how feasible is it to repair any defects in the short and long term? And knowing these consequences and knowing the answer to these questions will help decide the robustness of the system and the system type that is being considered now. So the standard classifies basements into 3 grades: 1, 2, 3, wet, damp, and dry. If we start with 1, a wet basement, probably a car park or a plant room or a workshop. Probably won't be any electrical equipment down there. And in a grade 1 basement, some seepage and damp patches is expected and is tolerable, dependent on the use. If we move on to a damp basement, so it will be plant rooms, workshops. There probably will be some electrical equipment down there. Water penetration is not acceptable, but dampness is accepted. And then when we come on to a grade 3 basement, it's exactly as it sounds, it's dry. It should be exactly the same as if it was built half a dozen stories above ground. No water penetration acceptable, and it's likely a combination of systems will be required to create this environment. If you actually look at the British Standard, that illustration from the previous slide looks like this, Table 2. There's a couple of key takeaways from this table. The first being that it refers to a grade 4 environment, which I didn't mention. That's primarily because they're no longer used and no longer exists. So instead, it guides you to ventilation instead. And the second key note, and probably the most important, is how to qualify dampness and seepage levels, as it's often subjective and it'll affect the design. The second note also refers to this guidance, the ICE, which provides these levels of seepage and dampness. And it also helps when considering the consequences of failure and any items to consider, which are listed here. And again, it's worth a read if you can lay your hands on it. So with the 3 grades of basement, there are also 3 types of protection as outlined in the BS 8102. So we have a type A, which is a barrier, which is exactly as it sounds. You place a barrier between the structure and the water in the ground. And some of them are listed there, and we will run through most of these. There's also type B, structurally integral protection, where the structure itself is the waterproofing system, and we'll run through that. And there's type C, which is a drained cavity protection. When considering which types to use, Table 1 of the British Standard should be referred to. And this table gives the suitability of the type of waterproofing protection based on the risks associated with the water table and the actual water table classification. So you'll see, as you look along the grid, that some of the high risk situations, some types of waterproofing are not deemed suitable, and others are only deemed suitable when used as part of a combined protection. And in fact, this was one of the key revisions to the 2009 revision of the BS 8102, was the use of combined protection, as we can see in this box here, to reduce the risk. And the theory being that the second system is a fail-safe. The other key changes at that time were the use of fully bonded membranes above other types. However, the standard is not comprehensive, as the note says here, and in fact it's a little vague. So selecting the correct product that has a correct performance is vital. Combined protection systems, or dual systems as we would call them, are now commonplace in the market, especially for sort of grade 3 environments. It is only a guidance or a recommendation in the BS 8102. However, many insurers such as NHBC and Premier now insist on 2 lines of defence for their grade 3 environments. So it's important to consider how the 2 systems work together, and also if one fails, is the other an independent standalone backup that doesn't rely on the primary system. There's now a little video which will illustrate such a dual system, which hopefully will outline the advantages and demonstrate how such a system may benefit your projects in the future. In this instance, the dual system will consist of Sika-proof fully bonded membrane and Sika Watertight concrete, and we'll look at it in a sort of typical basement construction. So here the Sika-proof membrane is the first line of defence against groundwater and any other harmful chemicals in the ground. It's highly flexible, it's robust, and it has outstanding crack bridging ability, and it offers a permanent waterproofing solution. You can see on our little basement here, the membrane's already been installed. So we'll take a closer look at it. It's highly flexible, and it comes with a unique grid sealant technology, and then it consists of a non-woven fleece, which achieves a strong mechanical bond to the concrete during hydration. The grid sealant technology means that the membrane is made up of little individual watertight compartments. So should any damage occur to one of these compartments, either during installation or afterwards, the leak is contained within the small area. So back to our basement, where the concrete has now been poured. In this case, Sika Watertight concrete is being used as the second line of defence of the dual system. So in standard concrete, only around 1/3 of the water in the concrete mix is required for hardening, and the rest is simply there for workability, amongst other things. The problem with this excess water is it creates many capillary voids in the structure, which can easily allow the passage of moisture. So with Sika Watertight concrete, the addition of the waterproofing admixture and an optimised water-cement ratio will create a dense microstructure within the concrete. There are 2 main technologies that relate to this type of admixture, both of which are shown here. The one on the left, Sika Watertight concrete powder, is a pore blocker, and on the right, Sika WT200 grows a crystal matrix across the pores. Both will permanently seal the concrete microstructure, and should the membrane be damaged, as we've shown here, the water is still not able to penetrate. There's also a range of complementary ancillary items that will complete the waterproofing solution. So if we look at Sikaswell, hydrophilic strips, these are used primarily in construction joints, but also for sealing around service penetrations. And you can see that they swell when they come into contact with water, creating a watertight seal. Sika Water Bar is a range of water stops that can be used either internally, as shown here, or externally, as shown here. And they're available in both metal and PVC, and they're used in construction joints, but also in movement joints, which is the example being shown now. Sika Fuko is a pre-installed injection system, and it's ideal for protection against not just water, but also salt water in construction joints. Once it's encapsulated in the hardened concrete, a resin or a microfine cement suspension is fed constantly into the system under pressure, and as you can see, encourages it to seal the joint. And finally, the CombiFlex SG system. It's a joint sealing system. It can be used for construction joints, connection joints, expansion joints, and even the repair of cracks. The system allows movement, and it will also provide a watertight seal. So the Sika Watertight concrete and the SikaProof membrane dual system offers fantastic protection, not just for this basement, for a wide range of applications. You can see this video again anytime you like by heading over to the Sika Waterproofing website. You'll find it there. So as well as the use of a dual system, there are some other noteworthy considerations in the British standard, which I'll run through here. So obviously the correct system and the ease of installation and detailing, particularly at ground level, when it's likely to interface with other types of protection. You should use experienced and trained installers. Are there suitable remedial measures for the system, and does it deal with any potential ground gases or VOCs and hydrocarbons on the project? And each project should be looked at based on its own merits. So which system to use? There are a wide range of type A's, B's and C's, and you need to evaluate the suitability. So let's look at some of the most commonly used systems in the UK. We'll start with type A's. Most often, or more often than not, they're referred to as tanking in the UK, and there are many different shapes and sizes of these types of products. And we'll look first of all at some pre-applied waterproofing membranes, specifically the SikaProof that we just saw in the video. So the membrane buildup is the polyethylene membrane, then the unique sealant grid, the non-woven fleece, and then the structural concrete. When it's placed on it, it bonds to the membrane, just as we saw in the video. Also, as we saw in the video, the grid sealant technology will prevent any lateral tracking of water if the membrane is damaged, and it will contain water in the little compartment up to 7 bar of water pressure. Why is this so important that I've mentioned it twice? It's not unusual or even uncommon for water to perhaps penetrate over on the right here, as we see, and then track laterally, and then show itself in the building at the nearest crack or joint, which makes investigation and repair of the leak difficult because you will likely look for the problem where you can see the water coming in, but in actual fact, the penetration is nowhere near there. So keeping the ingress to the single point is very useful. A key consideration with any bonded membrane is its durability and its life expectancy. So if we say the typical design life of a building today is 60 years, ideally you would want the system to be durable for that amount of time at the very least. And all of these systems that are listed on the table will perform at different levels against the factors on the left. Fully bonded membranes, simply, they waterproof the space that's to be protected, they protect the concrete, and in some instances offer gas protection, which we'll come on to. There's a section on that later. Post-applied waterproofing membranes, not dissimilar. Why post-apply instead of pre-apply? Post-apply simply means you apply this after the concrete has been placed. Quite simply, pre-applied membranes are not possible for every scenario, and especially for toes, kickers, precast elements, and also good for repairing holes left behind by the formwork anchors and the like. Additional benefits of Type A membranes, fully bonded membranes, and I say some will offer gas protection. Under BS 8485, bentonite systems are not allowed for gas protection. And other advantages are crack bridging ability to accommodate for concrete crack design widths, and also they're very fast to install, and usually there's no protection screed required for most of them. I just mentioned these, geosynthetic clay liners. It's two membranes, quite simply, that are interlocked by needle punching, and between these two membranes is a bed of sodium bentonite granules, which will swell and create a waterproof barrier when they come into contact with water. They're typically used on low-risk structures, and they do offer enhanced protection against sulfates in the ground, though. But they also require on compaction, so sort of positive pressure to hold them in place. We also have liquid membrane systems in the Type A range. Not so much for basement waterproofing, but more for podiums, terraces, balconies, piazza and plaza decks and the like. The main benefit of waterproof membranes, of spray-applied waterproof membranes, I should say, is the speed of installation and the fact that the system is seamless. So no interfaces, no joints, mean there's less likely a chance of water coming in. And we have a hand-applied version for small areas as well. So if you can't get all the kit and equipment 5 stories up onto a balcony, you can still use it. For the final Type A system, we'll move inside the building and we'll look at a multi-coat render system. In our case, that's Sika 1 Render, which was our very first product that was developed way back in 1910, and then it was used to waterproof rail tunnels in the Swiss Alps. BS 8102 recommends these types of systems for high-risk applications. Typically nowadays, we use it as in refurbishment situations, as it's placed on the inside face of the structure as opposed to the outside face. And there are different build-ups for the floor and wall, as you can see here. To reduce the risk and ensure quality control, we've pre-bagged these systems for the last 15 years. Previously, they were mixed on site, but that did and could lead to some quality control issues. So the new version of the system has the waterproofing admixture in the mortar bags, and you simply add water. The Combiflex SG system, which we saw in the video, is providing some additional protection here in the movement joint between the wall and floor, just to, as I say, give it some extra protection. And to complement the main Type A range that we've just run through, there are also additional coating systems that are available to complement the main product lines, and they all have varying uses, some of which have been listed here. But you can find information on all of these products on the Sika Waterproofing website. Type B, structural integral protection, or in this case, watertight concrete. So BS 8102 2009 Type B solutions are known as integral waterproofing. So that is where the structure itself provides the waterproofing protection. And this is where watertight concrete is typically used in the UK. You may have picked up from one of the earlier slides, it was one of the key considerations of the British standard was the use of watertight concrete to reduce risk. And simply, it is designed concrete with a waterproofing admixture. Why designed concrete? Because other than the addition of the admixture, there are some other key requirements, particularly the water-cement ratio. As mentioned in the video, there's far more water in a concrete mix typically than is required to make it go off. But as water is a natural plasticizer, it's required to help with placement, but it does leave behind lots of capillary pores that can allow the tracking of moisture. So the first step in creating watertight concrete is the use of a super plasticizing admixture. Now this effectively lowers the amount of water in the mix, which doesn't take away any fluidity and workability, as these admixtures effectively lubricate the particles of the concrete. So you still get all the flowable and workable aspects of the concrete you would expect, but with greatly reduced water content. So this reduction in water is crucial for reducing the number and size of the capillary voids that need closing. Step 2 is the addition of the waterproofing admixture. And if you remember from the video, there are two main technologies available in the Sika range. So the hydrophobic pore blocker, which is exactly like it sounds, it develops a polymer barrier across the pores, I should say. And the crystalline technology, which has slight self-healing properties in a sense that it grows a crystal matrix across the pores when it comes into contact with water. So as long as there is still moisture in the concrete during hydration, if any additional pores or capillaries appear, then it will continue to grow the matrix across the pores and continue to self-heal and protect itself in the early days. In addition to those two key points, the water-cement ratio and the admixture addition, crack control is obviously vital to the watertight integrity of the structure. The reinforcement should be designed to limit the crack width to a maximum width of 0.3 millimeters, as cracks greater than 0.3 can allow water ingress. Finally, the pore sequencing and ratios is crucial to reduce the risk of shrinkage and cracking, and other simple considerations like not having construction joints in the corners. It goes without saying that good concrete practice, proper placement, vibration of the concrete is absolutely essential. And cement replacement can still be used. Quite often cement replacement products are used to reduce the cost of concrete mixes. We can still have these with the watertight concrete admixture. With any watertight concrete structure, ancillary items such as water stops are essential to ensure continuity of protection throughout the whole building. And as we saw in the video earlier, they come in various types and sizes to suit different applications. So connection joints, construction joints, capping joints, and movement joints and more. The majority of them work on the same principle, which is the labyrinth principle, which I'll just explain briefly. So you can see in this instance, the water is trying to come into the structure via the construction joint. And when it gets to the water bar, it then tries to track sideways. And the theory being that by the time it's gone up and down all these little lumps and bumps in the PVC water bar, the water pressure has run out of energy and it can no longer force itself further up into the joint or into the structure. That's just a little, that's why there's so many different shapes and sizes of these, depending on the requirements. That's a little explanation of the labyrinth principle. The final protection type, type C, they're known as cavity drain systems. They're always inside the structure. They're typically HDPE membranes, 8 mils thick on the walls, 20 mil thick on the floors. And unlike other types of protection we've looked at up until now, they don't stop water on the outside face of the building. They let it in and then deal with it, quite frankly. Some key considerations when using them is you may require a sump, as we can see here, with a pump in it, or you can take it off into soil waste. But a key thing to consider is they do require maintenance, and it's crucial to their effectiveness long term. So you need to flush and rod the system quite regularly. So there will be visible access points such as manholes and little jetting points that you will have to accommodate. They're very good systems, and they don't limit the internal fit out or type of construction either, as there are many different membrane types that will accommodate the different types of internal construction. On our section on gases and VOCs, as well as waterproofing protection, gas protection is more often than not required nowadays, particularly as we build on brownfield sites and near old landfills. The most commonly found gases in the UK is radon, but also carbon dioxide, methane, and other VOCs or hydrocarbons that are in the ground and are a risk to health. So measures must be put in place to keep these out of the building if they're present in the ground. The ground gas standards, there are a couple. Methane and carbon dioxide is BS 8485. Radon, which is a naturally occurring ground gas, is BRE 211. VOCs and hydrocarbons, Syria C 748, and in general, Syria C 735 has good practice on testing and verification, and also BS 8102, the waterproofing standard, has some guidance as well. We'll look at methane and CO2 specifically. BS 8485 is the standard. The gas situation is scored based on gas presence and gas present and the building use, I should say. And the systems for protection are given a points value, and we have to meet those scores to satisfy the design. It does rely heavily on the quality of the installation, so qualified installers should be used. And obviously, if there is a waterproofing requirement, the system should be able to provide that waterproofing requirement too. Radon, as I mentioned already, is a naturally occurring ground gas, and here we see the radon map, which shows the typical levels found throughout the UK. They must be installed with care, but generally 1200 gauge polyethylene sheet membranes are adequate so long as the laps are taped as opposed to just left lying loose. VOCs and hydrocarbons, Syria C748 is the document that deals with these. So as well as an HDPE membrane, a film layer within the membrane will reduce the permeability. And the laps in these products generally require welding, as most of the tapes that would be used to join them, butyl or the like, will be affected and degraded by the actual VOCs. So just to summarise on ground gas and VOCs, the design of the gas protection systems should be appropriate to the ground contaminant conditions and the long-term use of the building, and the solution must be independently verified by a gas industry expert. So, coming towards the conclusion and a natural end to the presentation, just to sum up, the BS 8102, go too far, gives us 3 grades of basement: 1, 2, 3, wet, damp and dry, and 3 types of protection: ABC, barrier, structurally integral, and cavity drained. Once the grade is selected, how you waterproof the structure by using at least one of the 3 protection types, as we've ran through today. But it's vitally important that the client and designer understand and agree the expectations of the waterproofing types and the long-term benefits of it prior to the build commencement. So usually at least one, but more commonly nowadays, a combined protection of 2 minimal of these is beneficial. We at Sika provide the full range of these solutions, as stated in the British Standard and more, and we provide a complete solution from one manufacturer, which does have its benefits both during design and on site. So our aim at Sika is to work with you to get it right. We've been waterproofing since 1910. Given our long-standing history of products, our expertise and qualifications, we look to get it right with you by providing market-leading solutions that will take each project on its own merit with an unbiased view, because after all, we do all of these products, so we won't favour one over the other. So we do aim to give the project the best technical and buildable and commercial solution. Thanks for your attention for the presentation part, and I'm going to hand over now to my colleague Seb, who will engage you on the Q&A.
Thank you very much, Craig. So if you would like to get involved with the Q&A, all you have to do is head over to that panel, which will be on your right hand side, and you can post your questions into there and Seb will answer them for you.
Lovely. Thank you very much, Aoife, and thank you, Craig. Great presentation. And thanks for everyone who's listening. One of the questions I've got is what method of waterproofing do you think is best? Which is a great question. And really the answer depends on the type of construction, you know, whether it's a concrete reinforced basement or if it's going to be blocks, etc. It's really going to depend on the type of construction, the ground conditions, the water table and risk. But for instance, if it's a reinforced concrete box, you know, you can look at watertight concrete because you're already putting the concrete in. But one thing I would say is always consult an expert. These can be an independent waterproofing advisor, or these can be a supplier. If you're choosing a supplier, make sure that they offer a full range so their answer isn't biased in any means. The next question here we've got is, what is the life expectancy of watertight concrete? The life expectancy of watertight concrete should be the same as the duration of the design life of the concrete. There is no reason why the waterproofness of the concrete should be any different to that one. The next question here is the product available in the UK? And can any ready-mix supplier supply it? The simple answer is yes, it's available in all areas in the UK. We prefer the ready mixer to be accredited. There's two general forms of accreditation for ready mix concrete suppliers, and that's either QSRMC, the quality scheme for ready mix concrete, or BSI. But yeah, it should be available everywhere in the UK. Right, the next question. The next question I've got here is, do the products need to be installed by a specialist installer? Right, okay, the answer to this one is generally no. I'll go with the exception, which is the Seeker 1 render system. So the Seeker 1 render system, which is the multi-layered render for internal, we have specialist contractors which have been through thorough training, which are available from us. We can advise on that. They're the only real specialist, and the liquid applied sort of podium systems generally, because of the equipment involved in that, that's specialist contractors. But otherwise it's through a series of support on site through our technicians, our waterproofing technicians. So most other products, no, you don't need to be a specialist installer. The next question I've got here is, what is the biggest project we're working on? The biggest project we're working on at the moment is Hinkley Point down in Somerset, the nuclear power station. But I stress that we have a huge variety of projects, so there's no project sort of too big or too small to work on. Do we offer a range of repair materials? Yes. Okay, so repairs, we do for waterproofing. We have specialist contractors that would offer repairs for systems, but also we have a repair team which are under the name of Engineered Refurb, that offer full repairs and advice, etc. Let me see. Yeah, so I've got a question here on crack rips. Yeah, for Seeker, our minimum crack width is a minimum of 0.3 mil. So yeah, from a Seeker point of view, our crack width is less than 0.3 of a mil. And the next question I have, which is regarding the Seeker Fuka detail, and it's asking when this typically will be used. We use it a lot more in the tunnelling for shafts, etc. We use a lot more Seeker Fuka system. We're using it down at Hinkley Point. It depends whether you want to have a degree of maintainability in the future where you can go in and re-inject, or if you want to have a fail-safe system so you actually inject before, but I can go through that in more detail as well. Apologies if I haven't answered your question. I think I've answered everybody's question that's come up on my screen, but if there's any more questions that we've missed, we'll come back to you individually. But otherwise, thank you very much for everyone who's asked questions.